The Pasture Systems and Watershed Management Research Unit is located in University Park, Pennsylvania, noted on the map by the yellow star, which was chosen as the pilot site for the regional lab. The idea behind centralizing the laboratories is twofold. First, it frees up time for the agency scientists to focus more on project development, implementation, and dissemination rather than data analysis. Additionally, it alleviates the need for each of ARS's 90 locations to operate and maintain their own suite of analytical equipment or to budget for analysis to be done by a third party. Centralizing the labs also increases the agency's analytical capabilities as a whole, but it still offers the service at a lower cost than any single location would have. So here's a flow chart of the regional lab development process that we've started into about a year ago. So in the first box on the top left here, we went through and started to identify different laboratory analyses that we thought were pretty common across the agency. From there, we moved to purchasing some equipment and identifying personnel that would be either available or we would need to try and bring in at a later point. Once we had those figured out, we moved into developing protocols that were application or instrument specific, and at the same time we had started to develop a LIM system as well as a GTIN coding system. From this point, and this is kind of where we're at now, is sort of between this development part and the process testing part. We would go to ramping up to a point where we could start to look at the throughput capacity that we had at different stages, and then we could kind of circle back and change our protocols or change our information management systems. Once we were through that for a few iterations, then we could move on to the implementation of the regional lab. So 4 of the main areas within PDI are innovation, automation, standardization, and integration. The idea here is that we're trying to increase throughput, increase efficiencies, but still maintain the data integrity. So we have RFID tagging, QR coding for the samples themselves as being tracked through the process. We have equipment such as a balance that's network connected where there's no transcribing of any numbers. And we'll have standard operating procedures which would allow different processes from one lab to easily be transferred to another, but still maintain the exact same Another innovative tool that we've been working with is artificial intelligence and machine learning. Here we're using an AI software to go through and analyze spectra that have too many features in them for any single analysis to be able to work with. The software will go through and tease out different compounds, then use multivariate statistics to look at trends within the data sets. The data sets can be put together into one larger one, and from there we can make recommendations to the scientists who had sent the samples in to look for things they may have otherwise not even expected to see or known to look for. Ultimately, the goal is to have several regional labs throughout the country that would be able to serve the analytical needs for the entire agency, which is on the order of about 500 to 800,000 samples per year. The standardized process from sample submission to data retrieval would be identical, and one main repository would serve as the sole source of analytical information for the agency scientists.